Hi guys, welcome as we do the question before us. I read the question. Solve the simultaneous equations. We have these two simultaneous equations. Guys, we are going to solve these simultaneous equations using Laplace transform. And so guys, here is our question. I've already started to do it. The first thing guys, we write this in terms of Laplace transform. And so for dy dt, we have s Laplace transform of y0, and then for 2x we have 2 Laplace transform of x equals to Laplace transform of sine 2t. And for this we have s Laplace transform of x minus x0 minus 2 Laplace transform of y equals to Laplace transform of cos t. So the next stage, this is what guys we are going to have. So guys, this is what we have. For the first equation, guys, we come now and replace for y. And y here, as you can see, is 0. And then, guys, for sine 2t, the Laplace transform of sine 2t is 2 all over s squared plus 4. And the next equation, guys, we come and replace for x. And our term for x is equals to 1. That's when t is equals to 0, x equals to 1. And so, guys, I will put 1 there. Minus 2 Laplace transform of y, and here we have the Laplace transform of cos 2t, which is s all over s plus 4. Guys, now we continue. So guys, now we have eliminated 0 and we are left with this equation. Guys, we can now divide by s throughout. I divide by s here, divide by s, divide by s for this. So guys, after dividing, I can now take this on this other side. So that guys, you are left with one variable on this side. That is Laplace transform of y equals to 2 all over s squared plus 4. And then guys, I take this one on this other side. That means it will be minus 2 all over s Laplace transform of x, like that. Guys, with that, I can now replace my value, this value here, this value, I can replace in my second equation, which is right here. So where we have Laplace transform of y, instead of writing Laplace transform of y, guys, I'm going to write this figure. And so guys, I do exactly like that. So guys, I have, after replacing my term in this equation right here, where you have Laplace transform of y, guys, this is now what I have replaced. I have replaced this in this where we have Laplace transform of y, which is this, that is negative 2 Laplace transform of y. So instead of writing Laplace transform of y, guys, I have come and replaced. And this is what we are doing. It's actually a substitution method that we are using. After I have replaced, guys, I can take negative 1 on this other side so that it becomes a plus. And after that, I can expand or I can multiply 2 by whatever is inside here. And so we get negative 4 all over s squared plus 4 plus 4. This one now becomes a plus. And so from there, guys, we now continue. So guys, we are now going to factor out Laplace transform of x. And so the Laplace transform I factor out, and this term, guys, I'm going to make it go on this other side. And so when it goes on this side, it will be a plus. And here, guys, let's continue. And so, guys, we have factored out Laplace transform of x. And after doing that, we are left with the s now plus, this is now 4s right here. This is equals to, guys, this term we have brought it on this other side, it becomes a plus. So it's plus 4 all over s to bracket s2 plus 4, s2 plus 4. Now plus 1. From there, guys, I can place this under the same denominator. So it is s, and here we have s squared plus 4. Guys, the next thing we are going to do is that we can multiply by s to remove this denominator. We multiply by s throughout. So when we do that, we shall have Laplace transform of x, and then here we have s squared plus 4. We have multiplied by s here, and also here we multiply by s throughout s. So we shall have, this is equals to s squared all over s squared plus 4 plus, when we multiply by s here, this s will cancel. So we are left with 4 all over s squared plus 4, now plus s. So guys, from there now we can come and say Laplace transform of x, s squared plus 4 is equals to, guys, since these are not the same denominator, we can add them. This one comes to x squared plus 4 all over s squared plus 4, now plus s. And so therefore, guys, this now cancels. So guys, we are left with the Laplace transform of x, s squared plus 4 equals to 1 plus s. And so guys, after we have gotten this, we can divide both sides by s squared plus 4. This one becomes 1, so we are left with Laplace transform of x. And this side, it will be s squared plus 4. We can make this partial fraction so that both of them are under the same denominator. From there, guys, this is what now we are going to do. We can adjust this one so that this one fits one of the identity. And so I put 2 there. I also put a half. Of course, this does not change. And this one now becomes s all over s squared plus 4. Guys, now I look for Laplace transform on this side. And the that is inverse Laplace transform of x. This gives us x. So x is equals to a half, and then guys, the inverse of that. Just as we have done here, we also look for the inverse of that and also for the inverse of that. So for this, guys, this is going to be sine 2t and plus, now for this, s all over s squared plus 4 will be now cos 2t. Guys, as you can see, I have done it for you. I've gotten x, which is this. And now, guys, help me try to find what is now the value of y. Guys, you can do just as I have done. But now, guys, when it comes, because this is now substitution, we have done by substitution. Guys, now you can substitute for Laplace transform of x so that now you can get y. That is, guys, I'm talking about this substitution. Instead of substituting for Laplace transform of y, substitute for Laplace transform of x. So that now, guys, you shall be able to get Laplace transform of y. And so, guys, thank you for listening to me. Bye.